Hello everyone, my name is Dr. Chris Hacks, and today we're going to be doing CryptoPals Challenge number 2, Fixed XOR. So let's jump right in. I'm going to copy this real quick for our reference, and we'll go straight to the code. Okay, so first things first, we need to make a new file. Let's see, add new item, call this challenge number 2. Throw that in there, and at the top, like normal, I will paste the actual description. So fixed XOR. We're going to write a function that takes two equal length buffers. We'll use strings for this, and it produces their XOR combination. So you'll feed these two, and it should output this. Okay, perfect. So first things first, we need to jump into challenges.h. We're going to copy this and declare challenge 2. We go back to challenge 2 over here and get that all set up. This is just the structure we'll be using throughout the entire course. Make sure to include challenges.h. Alright, perfect. So what we'll do is we're going to use this fixed XOR function a couple of times later on. So I'm going to put this in encoding utils. Also, I noticed recently encoding util is named wrong. I'm going to go through and rename this to make sure there's an S here at the end. Alright, perfect. So we have all of our sort of conversion encryption type functions up here. So I'm going to give this function the fixed XOR its own spot. I'm going to put a new line for it. We'll make it return a string, and we will call it, yeah, we can just call it fixed XOR. That works. And what it will do is it will take two strings. So we'll call it input 1 and input 2. Okay, perfect. Let me make sure that the second string is a reference, just because we don't need to create any copies. Alright, so this function is actually pretty straightforward. If you aren't familiar with exclusive OR, basically what that means is you'll have two strings. Let's say we have that string, and we'll have this binary string. What exclusive OR does is it compares all of the different bits, and it will XOR them. So what that means is 1 and 1 will form a 0, because it's looking for exclusivity. So it's when the bits are opposite, it will set it to 1. If the bits are the same, it'll set it to 0. So here we have a 0 and a 1, so we get a 1. We have two zeros, so we get a 0. And then we have a 1 and a 0, so we get 1. So when these two binary strings are XORed together, you would get this output. So we're just going to implement that very quickly. And luckily, C++ has it all built in. We don't even really have to do any crazy math or anything. So first things first, these strings need to be the same length. If they're not, then we'll just return an empty string. So what I will do is if input 1 dot size is not equal to input 2 dot size, then we will just return an empty string. Plain and simple. You could also use dot length. Both are the same. Yeah, both functions are basically identical. So now that this one check is done, all we have to do is iterate through every single character and XOR them together. So what I mean by that is, let's first create our output to store everything. And we can also reserve size for it, because we know that it's going to have the same size as our other two strings. So output.reserve, and we will put just input 1.size. Okay, perfect. And for each character, so we'll just use character C, or I guess we would want unsigned. It doesn't really matter, to be honest. I could use auto for all I care. For each character, oh, actually, no, we want to use a just a normal for loop, because we have two different strings that we're working with. Times ti equals 0. I is less than input 1.size. We have I plus plus. I guess we could technically put input1.size in a variable and then compare it throughout all of this, but it really doesn't matter too much. Now all we have to do is this. Output of I is equal to, and then what we can do is we can grab input1 of I, and using the caret, that's the XOR function in C++, we can do input2 to I. And that's all that there is to it. Return output. Okay, very cool. So now let's go back to challenge 2, now that we have this fixed XOR function at our disposal. So we have these two strings, and they're hex encoded right now. So we have to hex decode them first. Let's do that. So const std string, let's do it like this. We'll have hex 1 is equal to this. Okay, and then hex 2 will be equal to this second one. Perfect. So now all we have to do is this. I'm actually just going to put it all in one statement. Return fixed XOR. Oh, I forgot to include the encoding utils header. That's important. Okay. Turn fixed XOR, and we will do hex to text, hex 1, comma, hex to text, and then hex 2. And that should be it for challenge 2. Let me go to the main function and actually switch it over. So we'll comment this out and just copy and paste it all. Very cool. All right, let's run it and make sure it works correctly. Assertion failed. I see. Okay, so we're gonna abort. Let's go figure out what went wrong. So first off, fixed XOR. No, that's fine. Conversion from okay, that's a function that we worked on last time. That we can take a look at later. Let's figure out what's going on here. Okay, so let's try this instead. Instead of using a accessor for output, we will just do this. Output.push back. And we can push back this. And because input 1 and input 2 must be the same size, it's going to have to do everything correctly. It can't do this unless these are the same size. So we only have to check one of the sizes. So let's try that again. Let's see if the pushback function will cause it to work correctly. Perfect. Okay. Oh, I forgot to turn it back into hex. So we have this fixed OR, and then we have text to hex. Okay. Very cool. Let's see what it says. And yep. So that is, yeah, there we go. Challenge 2 is complete. Now it was giving me a little warning earlier. It looks like the warning's gone. So, I mean, that's all we have to do. So that's how you complete challenge 2. Thank you all for watching, and I'll see you all in the next video.